Hello and welcome to a video where we're going to be talking about compound depreciation. So up until now what we've been talking about is compound interest, which is sort of where we put money into a bank and we watch our money grow over years, okay, where we calculate interest on the interest that we put in, okay? So remember that whole idea where I talked about that whole idea of interest on interest in class. However, compound depreciation is something that you might not have heard before, okay? If you look at the formula for compound depreciation, you'll actually notice that it looks really similar to the formula for compound interest, okay? The only thing that's different is that there's a minus sign instead of a plus. Now I'll explain what that is in just a moment, okay? So it's almost identical to the way that we would answer a compound interest question, okay, with A being our final amount that we end up with, P being our principal, so what we start with, our depreciation rate, which we often write as a decimal, okay, and I encourage you to do so in the questions that we do today, right, and N being our number of time periods, okay, or our compounding periods, as we would have said when we were talking about interest, okay. But what is depreciation and why do we have to care about it? Well, like I said, with putting money into a bank, into a savings account, we actually build up money, okay? And this could happen as well with when we talk about properties, for example. So say if I was to buy a house, over the years that I own the house, that particular house would go up in value, hopefully, okay? So we call this appreciating, so A for appreciating. That means it's going up in value, okay? But that doesn't always happen. What happens sometimes is we might buy something and it actually starts to go down in value. And the best example that I can think of this is with cars, okay? If you buy a car today, in 10 years, it will not be worth the same amount. It'll be worth less. So we say that car has depreciated in value, okay? So that means it's gone down. So D for down, okay? Now often the reason something might depreciate in value is because it could be less desirable, it could suffer from wear and tear, so you use the car each day to drive to and from where you need to get to, or quite often with cars, for example, there's a newer model available, so people are looking to upgrade, so that drops down the value of the car, okay? Now, what I want you to sort of understand here is that we can sort of graph the value of this car over time. Okay, so if we look at the value of the car here on the vertical axis, okay, and the number of years on the horizontal axis, our car will decrease in a decreasing exponential curve. And that's because it decreases by a percentage each year. It doesn't decrease by the same amount. Okay, in the lesson that I put online, you'll be able to see what I mean by that. Okay, but why don't we actually get into how we will calculate with these sorts of questions, okay? How we'll answer these sorts of questions if they were to sit in front of us and the types of methods and strategies that we would use, okay? So, let's get stuck into it. We'll do an example. Okay, so here's our first example. In this example, we say a coffee machine is worth $4,300 brand new when we buy it. If it depreciates by 5% per annum, what is its value after 10 years? Okay, so let's get a different coloured pen and let's go through and highlight the important parts of the question, okay? Notice here that it says it's worth $4,300 new. So that is its starting price, okay? We can call that its principal. It depreciates by 5% per annum, okay? So that's its depreciation rate. Now notice that I say the words depreciation rate here, not interest rate. It's because we're talking about the value of the coffee machine going down, not gaining interest in the value going up. Okay, and what it then tells you is what is its value after 10 years? Well, here in this particular section, what is its value? Okay, so its final value, that's going to be our A, right, after 10 years. And that gives us this number of time periods. Okay, now let's get into how we'll answer this question. Okay, so our final value, A, we don't know. Okay, right? Its principal, its starting amount, we do know. It's $4,300. Okay? Its depreciation rate, R, we do know. It's equal to 5% per annum. Okay? Now, the number of time periods that we have, well, it's in there for 10 years. And with these sorts of questions, okay, you are likely only ever to be asked when it depreciates annually. So not depreciation monthly or depreciation weekly. Okay, you'll only be asked depreciation annually. Okay, this is not like a compound interest question. So it depreciates at the end of each year, so once per year, so therefore your number of time periods will be 10. Okay? Now, in this particular question, we're going to use the compound depreciation formula, and we know that because, okay, it says the word depreciates in the question. So A is equal to P outside of 1 minus R, okay, make sure you put the minus in and not the plus, all to the power of n. Okay? So, let's have a look at how we would answer this question. We don't know what A is, so we're going to leave it alone. We sub in A is equal to, well, P is equal to 4,300. That's what our brand new coffee machine cost us. That's what it started off at. Multiplied by 1 minus, and you'll notice I haven't done something here that I did in other questions. So let's just do it now. What is 5% as a decimal, okay? And if you write 5% as a decimal, you just take that number and divide it by 100, you'll end up with 0.05, okay? So it is 1 minus 0.05, all to the power of n, our number of time periods, which is 10. Okay? On your calculator, you can simplify this down and tidy it up. So A will equal 4,300 multiplied by 0.95, all to the power of 10, after you tidy up inside of that bracket. Okay? Now, all that's left for you to do is to enter this in onto your calculator. Okay? So once you enter this in onto your calculator, what you'll end up with is 2,574.568 ... and it continues on going. Okay? Now remember, we want this to be as a currency, and currency in Australian dollars has a dollar sign and 2 decimal places. So we need to round our answer to 2 decimal places. We draw a line after our second decimal place, and we check, okay, after the line is an 8, therefore we must round up our number before the line, the 6. So that will become a 7. So our final answer is equal to $2,574.57. And remember, when you're answering these sorts of questions, you must tell people that you have now rounded it to 2 decimal places. Okay? Alright, so that's our first example. You'll notice that we have a very similar approach to how we do these sorts of questions. The only difference is that we take away the interest rate rather than adding it. So you can see here that we started off with a larger amount, the 4,300, and it quickly became a smaller amount, okay, which is what we mean when we talk about depreciation. Okay, we are talking about something starting at a higher value and declining until it becomes a lower value, much like a car or technology such as a computer, all of these sorts of options. Okay, so let's have a look at another example. Okay, so here for our second example, we're talking about a television set that originally was worth $1,250 and it depreciates at 6% per annum. So that means it goes down in value by 6% each year. Okay? Now notice that we're talking about technology. Technology tends to become outdated relatively fast, and that is why if you were to buy a computer 5 years ago, it would definitely be worth much less today. Okay? And televisions work the same. So it tells us, so let's go through and we'll highlight the question together. Okay? It tells us that it originally was worth $1,250 and it depreciates at 6% per annum. So it goes down by 6% per year. Now let's have a look at this first question. Okay? It is asking us what is its value after 7 years. So that gives us our time period. Okay? So let's go through and set out what we're going to do for this question. Okay? We're going to be using the compound depreciation formula. So A is equal to P outside of 1 minus, remember the minus, R all to the power of n. Okay? Now, let's take some time to set out our values in this formula over on the left-hand side. Okay? So it originally is worth $1,250. Okay? So we have our principal amount that we start with, $1,250. Okay? We have our interest rate at 6% per annum. And remember, this is asking us, what is its value after 7 years? Okay? Okay? Now, you'll notice that when I talk about depreciation, I only talk about it depreciating at the end of each year. Okay, so we don't need to adjust our interest rate in this sort of question. Okay, so let's just write this as a decimal. 6% divided by 100 will give us 0.06, okay, as our decimal. And then we look at our number of time periods. Well, it's 7 years. It depreciates 7 times. Okay, so n is equal to 7. We don't know what a is equal to yet because that's what we're trying to find. Its value after 7 years, our final amount. Okay, so let's start setting up this question, okay? We have a is going to be equal to our principal, 1,250, multiplied by 1 minus our interest rate, 0.06, all to the power of 7. Okay? We've just substituted this in. This is our P, this is our R, and this is our N. Okay? Let's do a little bit of tidying up inside this bracket, okay? You can enter that in your calculator if you want. Alright, and we'll end up with 1,250 multiplied by 0.94. 0.94 all to the power of 7. Okay? From here, we can enter this value into our calculator. We don't necessarily need the brackets in this case, but we can enter it straight into our calculator to end up with our value being $810.60. Now what I've done is I have rounded this automatically to 2 decimal places and just skipped a step here, okay? Normally I would get you to write out the decimals fully first and then round afterwards, but I just skipped that step, okay? So this is our final value corrected 2 decimal places. This is the value that a television is worth after 7 years with it depreciating, okay? Now, I want to have a look at the second part of this question, okay? So just give me a moment, I'm going to write this out. Okay, so the second part of this question is asking us by how much has it depreciated in this time, in the 7 years? How much has it gone down by? Okay, now to calculate this, we want to calculate the amount of depreciation. Okay, so the amount of depreciation. And what we want to do is we want to find the difference between its starting price and its final amount. Okay, so the difference between its starting price, or the principal, right? So when we say difference, we mean subtract in mathematics, minus its final amount. Okay? And the reason why we subtract the final amount off is because the final amount is actually smaller in these cases. Remember, we've gone down in value with depreciation. Okay? Now, the starting price, remember from our question, is our principal, 1,250. So this is equal to 1,250 minusing off our final amount. And we just found our final amount after it's 7 years. It's the $810.60. So $810.60. And what you can do here is you can then go ahead and whack these into your calculator, plug them in, and you'll come up with an answer of $439.40. Okay? So over 7 years, the amount of depreciation that's happened is $439.40. It's gone down by that much over 7 years. Okay? So, that's our second example. Okay? And what I ask you to do is I would ask you to keep this formula in mind because this will become very, very useful in a lot of questions that you attempt to answer. Okay? So, let's do one more example that's a little bit harder, a little bit more challenging. Okay? Right? And we'll end the video on that, okay, for something to think about. Okay, so for our final and more challenging example in this video, let's have a look at this, okay? The question states, a computer bought for $3,500 was sold 5 years later for $900. Find its annual depreciation rate, okay? So I'm going to look at the last sentence in this question, okay? You'll notice it says, find its annual depreciation rate. I'm going to pause this video and think in this formula. Okay, the depreciation formula. We know it's a depreciation formula because it says depreciation. In this formula, pause the video now and think what value are we finding? The A, the P, the R, or the N? Okay? Now, here's what we're going to do. We're going to highlight the rest of the question to draw out the important parts. Okay? It was bought for $3,500, okay? So that's its initial starting price, isn't it? It was sold 5 years later, okay? So that's its time period because it depreciates once per year, okay, for $900. That's its end price, okay, the final amount. So let's just take the time just over here for a moment to actually write out everything that we need. Our starting price, our P, is equal to $3,500, okay? Our interest rate, we don't know. Our time period is 5 years, okay? The only other thing that we do know is its final amount, A. And at the end of its 5 years, we are told that it is equal to $900, okay? So let's go ahead and try and solve this question, okay? This will be very similar to the type of skill that you used when you were finding the interest rate in the compound interest questions, but instead we're finding a depreciation rate, and this minus will make our steps just a little bit different, okay? Right, so let's sub everything into the formula for depreciation, okay? So our A is equal to 900, okay? Our P is equal to 3,500 multiplied by 1 minus, we don't know what R is, so we leave it as R, all to the power of 5, okay? So here's what we want to do. Just like last time, we want to try and unlock this bracket, okay? We need to get rid of everything on the outside of the bracket first, starting with this number out the front. Not the power, but the number out the front, okay? So in between this 3,500 and the bracket is a multiply sign. And remember, we do the opposite. So the opposite of multiply is divide, okay? So we're going to divide by 3,500. And what I do to one side, I must do to the other. Okay, we want to keep this equation balanced. Now, here what I have is 3,500 divided by 3,500. That will cancel, leaving me with 1. Okay, and we have just this bracket to a power left. 1 minus R, all to the power of 5. Now, what I encourage you to do is to jump on your calculator and simplify this down, and you'll end up with the fraction on the left-hand side of being 9 over 35. Okay? Now, remember, our next step that we had to do here was we had to unlock this bracket by doing the opposite of the power, okay? And then remember, the opposite of a power 5 was to take the fifth root of whatever was inside that bracket. So I'm going to take the fifth root of both sides, okay? What that will do is that will cancel out, okay, leaving me with just 1 minus R on the right-hand side, okay, and 9 over 35 with the fifth root of that on the left-hand side. Okay, now I'm going to move this up so you can see us having a little bit more room. Okay, so what I want you to do from here is I'm going to flip the equation. Okay, I'm going to put the 1 minus R on the left-hand side and the 9 over 35 with the fifth root on the right-hand side. Okay, so I'll end up with 1 minus R is equal to 9 over 35, and we take the fifth root. Now, we want to get the R by itself, and this is a common mistake that I see a lot of students make, right? I want you to understand here that in front of this 1 is still a positive. It is not a negative. That negative is attached to that R, okay? Not the 1. So, what we need to do is the opposite of the positive, the opposite of plus, okay? We're going to do the opposite of plus 1, which means we are going to minus 1 from both sides, okay? We're not going to add 1, we're going to do the opposite. We are going to minus 1 from both sides. Cancelling, leaving with us on the left-hand side, the minus R is equal to 9 over 35, fifth root, minus 1, okay? Now, what I want you to do is, just like on our last video, I want you to enter this particular value here onto your calculator, okay? So let's just take a moment, all right? I can't really do it here with this light, but if you enter it in onto your calculator, you will get minus R is equal to that decimal. Notice how that decimal is actually a negative, okay? Right, so let's write that down. We end up with minus R is equal to minus 0.237859 ... continuing on forever. So let me just move this up so you can see what's going on. Notice here that we have a negative on both sides, okay? that means that we can just ignore them. We are essentially multiplying both sides by a -1, so we can ignore the negatives because it's on both sides. So we have just r is equal to 0.23785 ... Okay? And what we want to do is, this is our depreciation rate, however, it's a decimal. We want to make this a percentage, okay? We want to get an annual depreciation rate as a percentage. And to do that, we need to multiply this by 100%. So you're going to take this number, multiply by 100, and add a percentage sign, okay? And what you end up with, this is equal to 23.7859 ... now, okay? Now this is per annum. It is a yearly or annual depreciation rate. Now let's just tidy up this depreciation rate and round it to one decimal place, okay? So after our first decimal place, we look at the 8, we're going to round the 7 up because it is higher than 5, okay? So we end up with 23.8% per annum. That is our annual interest rate, and you can see why this question now is actually a little bit harder than when we would do this with finding the interest rate in compound interest. Okay? The key things that I'd like you to pay attention to, and I'd like you to heed my words on, is to really, really be careful here in this step and make sure that you subtract 1 and not add 1. Okay? And to make sure that you carry this negative down until we got rid of it in this step. Okay? I hope that helps you out. And I hope your understanding of what depreciation actually is a little bit more than at the start of this lesson. Okay? Thank you very much.